Hello math enthusiasts! In this video, you will learn about geometric means. This video aims to define geometric mean and to find geometric mean or means between two terms of a geometric sequence. Let us start with this activity. Find the missing term or terms in the given sequence. You're right. It's -4 and -8. What about the next? Very good. -128 and 64. Next, you've got it. It's 3 and 1. Don't you know that these numbers are actually what you call as the geometric means? So that is -4 and -8 are the two geometric means between -2 and -16. -128 and 64 are the two geometric means between 256 and -32. And 3 and 1 are the two geometric means between 9 and 1/3. So what are geometric means? Geometric mean or geometric means are the term or terms between any two consecutive terms of a geometric sequence. So let's have example number 1. Find the missing geometric means in the sequence 648 blank 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 8. So in this case, you are going to find 3 geometric means. How are we going to do that? First, let us identify what are the given. So we have here 648 is our a sub 1. So that is our a sub 1. And 8 is our a sub 5. Why a sub 5? Because a sub 2, a sub 3, and a sub 4 are the missing terms. So we have your a sub 2, a sub 3, and a sub 4. So we have a sub 1 and a sub 5. And a sub 5 is actually our last term. So using the formula, a sub n is equal to a sub 1 times r raised to n minus 1. Do we have a sub n? Yes, that's 8. Do we have a sub 1? Very good. That's 648. Do we have r? Okay, very good. R is unknown. What about n? Do we know what n is? Yes, that's 5. So substitute all this given. So our a sub n is 8 equals our a sub 1 is 648 times r, which is unknown, and n again is 5. So 5 minus 1. So simplify this. What will we do? We're going to divide both sides by 648. So 648. So this will be cancelled because the quotient is 1. What about 6 over 648? You can simplify that as 1 over 81. So that will be equal to r raised to the 4th power because 5 minus 1 is equal to 4. So what's next? You can take the 4th root of 1 over 81, or you can express that as 1/3 raised to the 4th power, which is equal to r raised to the 4th power. So therefore, because the exponents are the same, we can simply say that r is equal to 1/3. So we have now the value of r, or that's the common ratio. So let's now find the three geometric means. Since you already have the common ratio, then a sub 2 will be equal to a sub 1 times r. So that is equal to 648 times r, which is 1/3. So that gives us what? That gives us 216 or 216. Okay, what about a sub 3? So a sub 3 is equal to a sub 2 times r. So what is a sub 2? 216 times r, which is 1/3. So that gives us 72. What about a sub 4? So a sub 4 is equal to a sub 3 times r. So what is your a sub 3? 72. That's right. Times 1/3. So that gives us 24. So therefore, the three geometric means are 216, 72, and 24. Okay, did you get it? Very good. Okay, let's have the next example. Insert three geometric means between 7 and 1,792. Okay, first, let us identify the given. Can you give one? Okay, yes, we have a sub 1. So our a sub 1 is 7. Okay, what else? We have a sub n. Okay, so what is our a sub n? So a sub n is equal to 1,792. And that is actually the, which term? Yes, that's the fifth term. Why? Because a sub 1 is 7, and then you're going to insert 3 geometric means, so you will have 1 plus 3 is 4. Therefore, 1,792 is the fifth term. Therefore, what is the value of n? N is 5. Very good. So, using the formula again, a sub n is equal to a sub 1 times r raised to n minus 1. So, let us substitute the given. So, you have 1,792 equals 7 times r, which is unknown, times n, which is 5 minus 1. What's next? Yes, divide both sides by 7. So that we have 1,792 is equal to 230 or 256 rather. Okay, 256 equals r raised to the fourth power. Where did we get 4? Okay, that's 5 minus 1. Then what's next? Okay, you can take the fourth root of 256, or you can express 256 as 4 raised to the fourth power. So 4 raised to the fourth power is actually equal to 256, and that is equal to r to the fourth power. Therefore, r is equal to 4. Okay? So I hope you still remember your lesson about radicals, no? When you were in grade 9. So since you already have the value of r, so we can now find the three geometric means. So again, so let us illustrate here. You have 7, you have blank, 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 and 1,792. So therefore, the missing are a sub 2, a sub 3, and a sub 4. So let's start with a sub 2. So a sub 2 is equal to a sub 1 times r. Okay, times r. Okay, so that is equal to 7 times your r is 4. So that is equal to 28. And a sub 3 is equal to a sub 2 times r. So what is a sub 2? 28. Very good. Times 4. So that gives us what? So 4 times 8 is 32. So carry 3. 4 times 2 is 8. Plus 3 is 11. So 112. Then a sub 4 is equal to a sub 3 times r. So your a sub 3 is 112. Okay, times 4. So we have 8. Sorry. So we have 8, 4, 4, or 488. So therefore, the missing terms are 28, 112, and 448. Okay, did you get it? Okay, very good. What if we are only finding for a geometric mean? For example, this one. Find the geometric mean between 5 and 20. So we're simply finding one term between the other two. Are we going to do the same process? Well, let's try first. So in this case, our a sub 1 is 5 and 20 is our a sub 3. So using the formula, a sub n is equal to a sub 1 times r raised to n minus 1. So our a sub n is 20. Our a sub 1 is 5. Then r is unknown. Then n is 3 minus 1. So, dividing both sides again by 5. So, divide this by 5. You'll have 4 is equal to r squared. Therefore, what is the square root of 4? So, it's positive or negative 2. So, r is equal to positive or negative 2. So, therefore, what is the geometric mean between 5 and 20? So, you have, since you have a sub 1 is 5, you're finding 4, a sub 2, so a sub 2 is equal to a sub 1 times r. So, a sub 2 therefore is equal to 5 times 2 if r is positive, and that is 10. Or 5 times negative 2, which is equal to negative 10. Do you get it? So there are two possible geometric means. So either positive or negative. Okay? But is there another way to do this instead of using this formula? Yes. So the other way to get the geometric mean between two terms is simply to get the square root of the product of the two terms. So that is the product of 5 and the product of 5 and 20. So that is actually equal to 100. And what is the square root of 100? That's positive or negative 10. So you've got this one. Again, so you don't need, in the second solution, you don't need to get the common ratio. Immediately, you're going to find the geometric mean. Okay, clear? Okay, that's good. Let's have the last example. In this case, let us apply the concept we had in example number 3. Insert a geometric mean between k and 1 over k. Here, we don't need to find the common ratio. We can immediately find the geometric mean by getting the square root of the two terms. So these are k and 1 over k. So that is actually equal to the square root of 1 because k times 1 over k is k over k or 1. So therefore, the geometric mean, which is actually equal to a sub 2, is no other than 1. Okay, is it clear? Okay, thank you. So with that, thank you. God bless you and happy solving.